All right. So the question is like, given a nested list of integers, return the sum of all integers in the list weighted by their depth. Each element is either an integer or a list, whose elements may also be integers or other lists. Okay, different from previous question where weight is increasing from root to leaf. Now the weight is defined from bottom up. Leaf levels, leaf level integers are weight 1. Okay. Okay, that means that when we don't really know what is the weight to be multiplied to when we encounter an outer list. All we can kind of do is uh, maybe we can do things negatively. So if I add the weight -1 and then -2 and -3 and -4, once I reach the final one, I know that that is supposed to be uh, in any case. I think here we can't really have add the sum as is. Uh, Once we reach the highest depth, we'll have to subtract that from each of them. So once we reach something like say 6 is the highest depth, we'll have to basically once we have gone through all of them, we have to save all of the numbers, all the integers in a kind of a list of tuples where we'll have the integer like the value saved, comma the second value would be the depth. So in this case, we will do a regular depth. So depth will be 0 for the outermost, and then save for the highest inner depth is like 5. So for some integer to come out to be 5, we'll keep a variable saying highest depth found, which can be set to 5 in this case. Now when we'll be trying to sum everything, we'll go from we'll start parsing the list from start to end, and we'll just check if the depth we'll actually subtract the depth. So we'll do highest depth minus the depth, and that will become the actual weight. So like 5 minus the 0 depth will become 0, so 5 will become the weight there. So that way we can kind of sort things out. Got it. Now in this case, the only thing is that leaf level integers are having weight 1. So we have to accordingly do that. Instead of 0, we have to consider leaf level to be 1. So we'll actually start with 1 in that case, and that should be fine then. So that when we reach 5 and then we do 5, um, so we can start with 0 and we can do +1. We have depth minus highest depth minus whatever depth +1. Cool. All right. So how do we do this? So if something like this was given, output is 8. Because 1, yeah, that we should be able to do. This is the interface that allows creating nested lists. You should not implement it, so we can't change anything. We have to reuse this interface only. So nested integer is what we'll get, and we can either check if it's an integer or yeah. So if this is false, basically it's a list, right? Then we can add, see this nested integer to hold the nested list, and add a nested integer elam. We can add another nested integer. This is the way you can set it. Okay, this actually initiates it as a list and then adds the element on that. Got it. So our first thing would be, as we parse, the outermost thing itself is a nested integer. They are saying it's a list of nested integers. so we can pass through it. So for nested integer in nested list, and we have to store, right, some tuples. Now for every nested integer, it could itself be a list or it could be a integer itself. So if you know nested integer dot is integer, you need to kind of keep a track of the depth. So maybe depth starts at 0 outside, and we have to have operations which can both increment the depth and decrement the depth, right? So if nested integer is an integer, we'll use the current depth, and depth will at any point represent the current depth. If it's an integer, we'll get that integer and we'll add it to sum. So in that case, we're gonna sum tuples out of n, and that would be nested integer dot get integer comma the depth. Else if it's not an integer, then it's a list, right? So if it's a list, it's always gonna return a value. Now if it's a list, then we can increment depth, right? And need to somehow call this entire thing again, so it needs to be somewhat of a recursion. So maybe we'll have some inverse helper. I usually just name it with the same thing but with the helper and we can pass it a nested list and depth. And initially what would we would have done, and then this entire thing could be inside. Else we can just call this and rely on that to append it to some tuple. Some tuple is outside, so we should be able to access that. And that plus one, right? When it exits this, it'll come back to the previous guy and keep nesting, and that time depth would be whatever depth was. Cool. So and then now we can just call this with the nested list original and depth, which was 0. So now what we supposed to have is that we will have some tuples including just the integers and their depths. And now once we have that, all we need to do is, we need to track highest depth also. So if depth is greater than highest depth float minus infinity, and we can just do highest depth equal to max of depth and highest depth was there. So that way at least will be 0. And now what we can do is we can output would be a number. Now what we'll do is we'll go through the tuple. So for num comma depth and some tuples, we're gonna add num into your highest depth minus its depth plus 1. Fair. And then we can return output. Maybe we can, we are only about 9 minutes in, so maybe we can do a quick try run with these cases. I'm sure we'll find some or the other issue that always happens. So this is the actual thing that's passed. We'll go inside, right? The first element that comes up. So Sum tuples is empty list, depth is 0, highest depth is float minus infinity. We call this a nested list, which is the thing that is passed to us, and the depth is 0. So it goes inside, highest depth gets set to 0. For nested integer in nested lists, it picks up this guy. It checks if it's an integer. It's not an integer, so it goes into this, and depth will become 1. So it's gonna pass. Oops, it has to pass nested integer. See, silly mistakes. So once it passed the nested integer, that's supposed to be a list. That's why we passed. And depth is 1 now. So highest depth becomes 1. It's gonna go inside of it. It's gonna get 1 is an integer. It's gonna add that to, like, hey, get that integer like 1 and get the depth also. So we'll have in our tuple we'll have a 1 comma 1. Then it's gonna go till the next integer. That's also an integer, so that will also get come up here 1 comma 1. Then this thing is over, so it's gonna just go back. So we come back here, and this had happened for this element which we have processed. So it's gonna go to the next thing, which is 2, and depth is again 0. So this is 0, and now 2 comma 0 is gonna come up, and then we're gonna go again, and it's gonna be not an integer, so it's gonna call this guy, and that's gonna check, and this will again be 1 comma 1 and 1 comma 1, and that should be it, right? So that is what we'll get. Now when we go here, output will be 0. It will pick up num and depth in sum tuples, and it's gonna output num and 2, so it will become 0, then it will change to 1 into highest depth we found was 1, so 1 minus 1 plus 1, so 1, and then 1 minus 1 into 1 minus 1 plus 1, 1 plus 2 into 1 minus 0 plus 1, so 4 actually, 4 plus 1 into 1 minus 1 plus 1, 1 into 1 minus 1 plus 1, 4, 5, 6, 7, 8. So this will give us 8, which is correct. Now this is a slightly more interesting case. So we'll go inside. The first will be integer, so we'll have like 1 comma 0. Then it picks up this element, right? And it's gonna check the first integer will come up, which will come up here, so 4 comma 1. But the second element itself would be a list. So it's gonna go with calling it, and depth will be 2, and this will come up and give me 6 comma 2. And this, when we check, we'll say 1. Highest depth will come out to be 2. So 1 into 2 minus 0 plus 1 is 3. So 3 plus 4 into 2 minus 1 plus 1, 2, 8 plus 6 into 2 minus 2 plus 1, 6. So this will give us 17. So this seems to be fine. I think we are returning the output also, so let's just see if this works. Highest depth reference before assignment. Why? Maybe let's just keep this itself. And now wherever we are using highest depth, that will change. Depth we can keep like this, because that's something that we need to pass as a number. And then this depth, this is also depth. So we'll dot sum tuples here. Right, and now here we again check and sum tuples and highest depth. Right, and this we can return. Nested integer object is not iterable. Oh, get the nested list, that is nested integer always. Nested list. Okay, so dot get list. So now what we'll do is, in the first case, obviously we are given a list of nested integers, so it's fine. But here it's a nested integer. But we know it's a list, so we need to get its list and pass that only, so that we are sure that this method always gets a list here, which it can iterate over. Right, that makes sense. Uh, let's just see if this submits. Yes, it submits. It's fastest also. Memory, it has used a lot of memory, I guess. Where is it using a lot of memory? Probably to keep these sum tuples, right? Maybe this was possible to do without the sum tuples. Uh, Not sure how, but probably it was. Anyway, we are done with this.